Alright, so today we are on day 2 and we are solving systems with substitution. Okay, quick review from yesterday. We talked about systems of equations. System of equations is when we have two or more linear lines put together and we're trying to find out what solution could solve for y and x, or x and y, that would make both statements true. Yesterday, we graphed. That's all you did for your homework, was we graphed all these lines. What did you guys not like about yesterday's homework, about graphing? Besides that, it was homework. That what? What do you mean it was long? Okay, 13 questions. How many you had to do? What else about graphing? Ainsley?
It's not like some of them I had to do like a couple times to make sure that it actually looked like a okay. I'm sorry my words, sorry, but I had to redo it a couple times to not perfectly, but to get the answer for the y equals.
Sure. Finding where that intersection line is. Even if we looked at our homework, I said, this one, it took me a little while because it didn't land exactly on that coordinate point. It didn't land evenly on the graph. And it looks like it's at 7.5, but I don't really think it's at negative or at positive 3. I said 3 on my answer key, but I think it's actually just a little beyond. I don't know if it's at 3.5 or if it's at 3.25. That's my problem with graphing. And that's why I typically will not use graphing. Is I like graphing if it came out even, where it landed on whole numbers. But things like this one, or even up here, let's see, where's it at? Yeah, it crossed right there. If your line isn't perfect, it messes you up a little bit. So that's really where it almost put more stress on what it should have been. So that is one method, though, that we can use. Today, we are going to work with a second set of solutions. By the way, I think I mentioned this to you guys. Did anyone work on this part and do it? If you do it, I told the last class, it's just a puzzle. It relates to today's homework. But if you do it, I'll give you a dum-dum sucker for the puzzle you solved. So, nothing big, just extra credit. So, your choice if you want to try and solve it. It's just one of those little puzzles. Alright, so let's look at today. Today's method that we are going to work on is substitution method. Now, I mentioned this with my algebra class. They're doing the exact same thing you guys are. And I like substitution. It's the one that I'll use probably 95% of the time. It's just the one I'm most comfortable with and I like the best. Not everyone loves it. Some people like it. I do. So, right now we have to learn all 3 methods. And then in real life, you get to choose which one you want to use, whichever you're most comfortable with. So we did graphing, now substitution. So the steps to solve substitution. Step 1, we need to take the equation and we're going to solve one equation for x or for y. Meaning, when we have the equation, like up on the board, I have 2x plus 4y equals 15. We want to solve that either for x, so it says x equals. So we get x equals. Or I want to solve it for y, so I get y equals. Yeah? So step 1 is to make sure we do that. Step 2, we're going to use the word substitute, which is exactly what this method is called. Substitute this expression into the other equation and solve for the variable. Once I've rewritten the equation as y equals or x equals, I'm going to just, so I don't get confused, I'm going to say x equals, and I get x equals, Let's write something on the board. Say I took this equation and I rewrote this one. So it was 2x equals negative 4y plus 15. If I divide by 2, x equals 2y plus, we'll say 7.5. Okay. That was step 1. You see how we have x equals now? Step 2 is I'm going to take what x equals. If x is the same as saying 2y plus 7.5, I'm going to take this 2y.75 and I'm going to go to my other equation and input it in for x. I'm going to substitute it for x. And that's what step 3 is going to talk. After I've done that, and I've solved for the variable y on that case, now I'm going to come back over here, and I'm going to say replace or substitute, doesn't really matter. I'm going to replace my answer into the revised equation from step 1. I'm going to go back to step 1, the revised equation, and solve for the other variable. This will make more sense when we get a little bit into the examples. Okay? It becomes pretty clear. The first couple examples, they use step 1 for us, which is a huge help. So pay close attention to this, and this will really help you. Here's our example. System of equations. I have y equals 4x minus 1 and y equals 2x minus 5. Now, we're lucky on this one because they've actually solved for y on both of them. So I can actually use either one. But I'm going to go ahead and highlight 4x minus 1. Okay, what I'm doing is I'm saying if y equals, that means y is 4x minus 1. If Zachary says I have y, and I said I have 4x minus 1, we have the same amount. Because y equals 4x minus 1. You have to get that part under, you have to understand that part. They equal the same amount. What I'm going to do is I'm going to substitute that into my second equation. Okay? That's our substitution. So I'm going to take the second equation and I'm going to say y equals 2x minus 5. And instead of having a y right here, I'm going to substitute in what we said y was on the previous equation, 4x minus 1. So I'll say 4x minus 1, that was replacing y. And that needs to equal 2x minus 5. Because I've done that, I now have an equation with only one variable. This takes us back about 2 or 3 chapters ago. Remember when we solved equations? This is a 3-step equation. That's all we're doing. Now we're going back to what we learned earlier in this year. I'm going to solve for x because there's only one variable in here, x. To do so, I'm going to subtract 2x from each side. If you want to draw that little boundary in here, you can. I'm showing all my work. 4x minus 2x is 2x. I still have minus 1. 2x minus 2x is nothing. And I have negative 5. I want to get x alone, so I'm going to add y, or add 1 to each side. 2x equals negative 4, because negative 5 plus 1 is negative 4. I then want to get x all by itself, so I divide by 2, and I would get x equals negative 2. Okay, so not too bad. I mean, we've done this. We've tested over how to solve equations. So I'm going to go over here and I'm going to write x equals negative 2. I still need to find out what y equals. This is step 3. Replace your answer. Our answer was x equals -2 into the revised equation from step 1. Well, our step 1 was y equals 4x minus 1. So I'm going to go back to that first equation. Y equals 4x minus 1. But this time, I know what x equals. So I'm going to substitute that in there. I'm going to say y equals 4 times x. Well, what is x? -2. We found that in the previous problem. -2 minus 1. And now I'm just going to solve the equation. Y equals 4 times -2 is -8. And I still have my minus 1. Y equals -8 minus 1. Careful with your integers. Right? -9. And that is my answer. X is -2. Y is -9. If we were to do yesterday's work and we would have graphed each line, it would have came out to -2, 9 is where they would have intersected. Okay? So I could have graphed it, and I would have got the coordinates -2, -9, or we can use substitution to get it. We're going to do a few more. I'm going to tell you already what I'm going to do is, I told my 4th hour class, because we're not going to get through all of our examples, and I want you to actually, I'd rather you start the homework than do all these examples with me. But during 8th hour, when I don't have students have plenty of time, I'm going to record and do all of these, and then I'll post it on today. So if you're doing your homework and you're confused, you can go back and I'll show you all the steps on every one of these, okay? Let's look at number 2. It says y equals 6x, and the second equation is 2x plus 3y equals -20. Well, if we think about number 1, do either one of our two equations solve for x or y already? The first one does. So I'm going to choose that one so I don't have to do extra work. This first equation says anywhere you see y, just put 6x in for it. Okay? So in the second equation, there's a y, and I'm going to replace y with 6x. It's hard to say real fast. Alright, so here's what we're going to do. 2x plus 3, and this is me substituting. Since it's substituting method, I'm substituting y, and I'm putting 6x in. And that has to equal, finish my equation, -20. Now all I'm doing is solving this. This is now our 4-step equations that we would have done in chapter 2, because there's a distributive property in here. I would do 2x, 3 times 6x is 18x equals -20. What's the next step we should do? I want to solve for x. Avery, what do you think? Good. We want to combine like terms. Because I have one variable x, and so I can add my coefficients. 2x plus 18x gives me 20x. Okay? So I have 20x equals -20. Very good, Wade. I have 20 times x, and that's all I have left over there, so I want to get x alone. We divide by 20. X equals, and careful on this. It's really simple, but I've had some people make a mistake. -20 divided by 20. Negative what? 1. For some reason, even, I don't know why, this is messing with me. I've had a couple of people say in my head, I keep thinking -2. But 20 divided by 20 is 1, and it was a negative. So I have x equals -1. Now, 4th hour, I asked students this, and they got it right where they would have done it correct, but there's an easier way. Now that I've known x, we're doing substitute method, so I'm going to substitute x in for, or I'm going to substitute negative 1 in for x. Which equation should I put negative 1 into? Should I do y equals 6x, or should I solve for 2x plus 3y equals negative 20? You're right. I can do either one. It does not matter. Because we're finding the solution. Negative 1 does go here. It does go in 2x. I can put negative 1 in there. I can also put it in the first one. Troy, why do we want to do the first equation though?
It's already solved.
Well, for the most part, it's already solved. I have only one y there. Plus, it looks like there's only one step to do. I'm just going to times 6 times my x. So, y equals 6x. I'm going to substitute in. X was negative 1. Okay, so y equals 6 times negative 1 is negative 6. My answer is negative 1, negative 6. Continue to write this as a coordinate point for me though, because, once again, if we would have graphed this, I would have got negative 1, negative 6. Could I have put negative 1 in for 2 and done 2 times negative 1 plus 3y equals negative 20? Yes. And when we solved, we still would have got that y equals negative 6. But pay attention. Since you're going to be doing work, try and do the one that's going to require least amount of work. Okay. I want to do 2 more, and then I'm going to get you started on your homework, and then I'll do the rest of them. I want to do number 3 and 5 for you. So number 3, y equals x plus 9. I noticed that they've already solved for y. I have one y, so I'm going to substitute that in. Wherever I see y on the next equation, I'm putting x plus 9. So, second equation was 3x plus 8 times, and I'm putting in this x plus 9. This is a 4-step equation that we're solving. I know it because there's distribution here. So, 3x, and be careful. This is the part when we went over this chapter where people made mistakes. When you distribute this 8, it's a positive 8. Pay attention to that symbol in front. If it was minus 8, you're multiplying by a negative 8. So, positive 8 times x is positive 8x. Positive 8 times 9 is 72. We finish our equation. Now, Avery told us the last time after we do distribution that we are going to combine like terms. I'm going to do the same thing there. 3x and 8x says adding, so 11x, good. Okay, now I have a variable and a constant, so I got to switch them on sides. Minus 72. And I'm going to get 11x equals negative 77. And Wade told us on the last equation, when I have just a coefficient and variable on the left side, I can divide to undo multiplying. X equals negative 7. Okay. We still have to find y. So, what am I going to do now? Where am I going to put in negative 7? X is negative 7. Where am I going to input that? Right? Yeah, let's go to the first one. That's the easier equation. Y equals x plus 9, or 3x plus 8y equals negative 5. Obviously, the first one's easier. I'm going to put that negative 7 in for x. Y equals x, negative 7, plus 9. Negative 7 plus 9 is 2. So y equals 2. Negative 7, 2 is our answer. The toughest part is finding your first variable. Once you've done that, replacing it on the second one is usually pretty simple. Alright, last one, and then I'm going to give you homework. I want to do number 5, and there's a reason for it. What do we notice different about number 5 than the other 3 that we just did? None of them are completely solved yet. On 5, we have 2x plus y equals negative 2. Okay, they didn't tell me what x equals or what y equals. The second one, 5x plus 3y equals negative 8. They don't have x equal or y equals. So we have to solve. We only have to choose one of those equations. We only have to solve for x or y on one of them. Which one do you want to do? There is one that's probably easier. Yeah, top one. There's 2 reasons. One, I see that there's only one y. Over here, there's an x and there's y, so I know I'd have to divide. So this one is the best one. So I'm going to say 2x plus y equals negative 2. And I want to solve for the y because there's only one y. So I'm going to subtract 2x from each side. Y equals negative 2x minus 2. I am done with that first step now. I've solved. Y equals negative 2x minus 2. However, do I know what its one digit is yet? No. But I can now do today's whole thing is about substituting. I can now substitute negative 2x minus 2 in for y. So I'll go to my second equation. 5x plus 3 times, this becomes a distributive property. Negative 2x minus 2 equals negative 2. Oops, I went to the wrong equation. Sorry. Equals negative 8. Make sure you write the equation right. Okay, we distribute 5x, and I'm going to distribute a positive 3. 3 times negative 2x is minus 6x. 3 times negative 2 is negative 6. Avery, can you tell me what we do now? Good. Combining our like terms. 5x and negative 6x. So 5x minus 6x is negative 1x, or just negative x. I think it was Troy that told us we got to bounce that one over. So I'm going to add 6 to both sides. Now I have negative x equals negative 2. How do I get rid of a negative x? Just erase the negative sign. If it was over that easy. I could add an x over, but then I'd have to add the stuff on the other side, right? Because otherwise I'd have negative, if I added, Troy, if I added x, I'd have 0 equals negative 2 plus x. Well, what's x equal?
X is always
X is not. There's only one x in here. We have to find what we substitute x in. If we did this, we would have to add 2, and then we could say 2 equals x, and that's okay. X equals 2. You can do that, or The only problem is if there's a lot of stuff on the other side. What's the other way? You guys remember, Ainsley? Yeah, we can divide it. And I can either divide by -1 or I can multiply by -1. If I divide by 1 or multiply by 1, nothing changes. But when I do it by a negative, it changes the sign. So negative x becomes x. -2 becomes 2. So x equals 2. And now, to finish it, we have to solve for y. Do I want to go back and put y in right here? 2x plus, or no, sorry, for the x. So I want to say 2x times 2 equals -2. I could, or like they said before, I can put it right in here. This was what they talked about in our work, and put in the revised equation from step 1 and solve. So if I go to my equation right here, y equals -2x minus 2. Y equals -2 times, we said x was 2. Y equals -4 minus 2. Y equals -6. Do not get confused. You could have put 2 in for x in this equation. You could have put it in here. You could have went in and put it in there. Or like we did, we put it in this one. It does not matter. Once you have your first variable solved, to find the second one, substitute that first variable into any of those equations. So your final answer was 2, -6. Okay? You are going to be doing this today. Your homework. You could probably think 4th hour, specifically, I think Sydney's the one that talked me into it. There were 16 problems to do.
That's funny.
What was that?
16.
You can do 16.
No. Give us 10.
I
10. Give us 10.
Like, give us half.
Listen to what
16 was the idea. That was the point. I am doing a completion grade still for this, just like we did yesterday. But they talked me into only have to complete the evens.
No, we didn't. We talked to you.
No.
We talked you into it.
I'm going to make you guys this deal, so I want you to make sure you're listening to this. If I am changing your homework from 16 problems to 8, I like giving you guys homework about 10 questions long. I've done that ever since elementary. I always feel doing 10 problems. If you do those 10 and you do them well, you kind of start to understand the concept better. If you're getting it, doing 20 and 30, you kind of get a little more fluent, become a little more well known with it, but it becomes kind of redundant, and sometimes it burns you out. So I'm okay with trying to only give you guys 10 homework problems a night. But if I'm going to cut our homework down, and I'm doing it so everyone only has to do 8, I'm making it 8 questions so we get our assignment done. I expect everyone to do their homework. If we're just going to not do our homework, I'm not going to cut it down and make it easier. I'll just leave it where it is. But cutting it down to 8 problems and we still have 10 minutes of class, you should be able, we did a couple of them in only a few minutes. You should be able to at least get 2 to 3 of them done. Then you're almost halfway done. Homework should not take you too long to do. So, I'll give you this worksheet. Take your notes. Make sure you put them in your 3-ring binder. So, you should have day 1, day 1's homework, day 2 notes, and for homework, you are doing the evens.